Hey, today I will be doing a lesson on multiplying radical expressions. So our product of radicals rule is a times b equals, the square root of a times the square root of b equals the square root of a times b. So for example, we have the square root of 6 times the square root of 24 equals the square root of 144, which equals 12. If you remember, back when we did adding and subtracting radicals, we added and subtracted whatever was outside of the radical, but left what was inside the same. This is different. When we're multiplying radical expressions, you actually multiply what is underneath the radical. You multiply the two radicands together. So 6 times 24 is 144, and the square root of 144 is 12. Just note that a and b must be real numbers to use this property for multiplying real numbers. So if we try some of our own, we have the square root of 2 times the square root of 8. Well, 2 times 8 is 16, so it equals the square root of 16, and the square root of 16 is 4. Okay. For the next one, we have the fourth root of 4 times the fourth root of negative 4. Well, 4 times negative 4 is negative 16. So we have the fourth root of negative 16. But think about it. Can we solve that? You have a fourth root of a negative number. If you remember from the first lesson of simplifying, you cannot simplify a radical with a negative under it that is even. If it's odd, you can, but any even radical, you cannot simplify if the radicand is negative. So there's actually no solution for this one. Next we have the cube root of negative 5 times the cube root of 25. Well, negative 5 times 25 is negative 125, so we have the cube root of negative 125. And we can have a negative under the radical if it is odd. So notice that 3 is odd, so this one is possible. If we break this up, it would actually be the cube root of negative 5, and negative 5 is the same thing as negative 125. So our answer is negative 5. For our last one, we have the cube root of negative 16 times the cube root of 4. Well, negative 16 times 4 is negative 64. So we have the cube root of negative 64. And like I just said, we can have odd indexes with negative radicands, but we cannot have even index with negative radicands. So the cube root of negative 64 is negative 4. If you'd like to put it in your notes, I'll write right here. An even index cannot have a negative radicand. An odd index can, and the answer will be negative. So make sure you have that down if you need it. An even index cannot have a negative radicand, but an odd index can, and the answer will be negative. Make sure you get that down in your notes if you need to. Okay. If you need to see all these problems worked out again, Here's all the work form. Make sure you get it in your notes if you need it. For the following problem, we're actually multiplying with variables now, not just numbers. So I'm going to write this one over here so I have a little bit more space. We have the cube root of 25x times the cube root of 125x to the fourth. Before we multiply, we can actually simplify the second radical expression over here. The cube root of 125 is actually 5. And the cube root of x to the fourth, if we were to break that down, we would have x times x times x times x, and we'd be able to circle 3 of those. Here, I'll break it down. 125, you'd have 25 and 5, and then 5 and 5. So when I write it out for my prime factorization, I have 5 times 5 times 5 times x times x times x times x. Remember, I need 3 because my index is 3 in order for 1 to come out. I have 3 5s right here, 5, and I have 3 x's right here, x. So I'm left with 5x times the cube root of x. So now I can multiply those two, which means I would have the cube root of 25x times 5x times the cube root of x. And when I multiply these, I have nothing to multiply 5x with because there's no number outside of the radical over here. So it just stays 5x. It's still a cube root. We never change the value of our root when we're doing these. And we have 25x times x. Well, that is just 25x squared. Okay, so that's the answer to E. For F, we have the cube root of 27a to the fifth times the cube root of 4 times a times b squared. So I can also break down 27. 27 is 3 times 3 times 3. So I'm going to go ahead and pull the 3 out. And then a to the fifth, I can pull 3 of the a's out because I have 5 of them, but I have an index of 3, so I can pull 3 of the a's out. So that gives me 1 a on the outside. Remember, I would circle 3, but I would only pull out 1. So then I'm left with the cube root of 27 is 3, so there's nothing left of that. But a to the fifth, remember I circled 3 a's, pulled out 1, which means there's 2 a's left. So I have an a squared left. And I'm multiplying that. I can't simplify the second one, so I'm just going to rewrite it. 4ab squared. Okay. Now that they're both in their simplest form, I can multiply them. There's nothing outside of the radical for me to multiply 3a with, so I'm just going to rewrite it. We're still in a cube root, so I rewrite the cube root. And then I have a squared times 4ab squared. That would be 4a cubed. Remember, I add my exponents. I do not multiply them from the laws of multiplying exponents. And b squared. Well, if you look, we're actually not done because I have a cube root of a cubed. So I can actually pull those 3 a's out. If I was to rewrite this, I would have 4 times a times a times a times b times b. Well, I could circle those 3 a's and pull 1 more out, which means I would have 3a squared, the cube root of 4b squared. If you'd like to see me work that one out, specifically, if that confused you a little bit, put a question mark, and I'll work it out in full length in class. Just let me know. Let's the answer for F. So for multiplying by distribution, okay, we're just going to do exactly like we would if we had x's and y's. So I'm going to do my first one here. Square root of 5 times 4 is just 4 square roots of 5. And then multiply the second one. So square root of 5 times 2 square roots of 5 is, when I do the square root of 5 times the square root of 5, that's like the square root of 5 squared. So that actually cancels. So I would have, we'll do it like this, plus 2 square root of 5 times square root of 5. Well, the square root of 5 times square root of 5 is just 5. So I actually get 4 square root of 5 plus 10. The square root of 5 times square root of 5 equals 5, and then 2 times 5 is 10. So that's for A. On B, do that one a little bit to the side here. I have 4 square roots of 7 times 5A, so I'm going to distribute that one first. So 4 square roots of 7 times 5A, there's no other radical for me to multiply by, so I actually leave what's under the radical alone. So 4 times 5A is actually just 20A square roots of 7. And then for the second part, I have 4 times the square root of 7 times negative 5 square root of AB. Well, I multiply what's on the outside together. So I have 4 times negative 5, which is negative 20. And then I multiply what's under the radicals together. So I have square root of 7 times square root of AB, which is just square root of 7AB. Sorry, guys. There you go. If you notice, what my radicands are different, so I cannot subtract those. When I do C, we actually have to do our double distribution like we've been practicing. So I'm going to do 3 times 4, 12. Then I have 3 times negative square root of 3, which is just negative 3 square root of 3. Then I have to do the bottom ones. And I have 6 square root of 5 times 4. So I get 24 square root of 5. There's no other radical for me to multiply with, so I just multiply my numbers that are outside. And then for the last one, I have 6 square root of 5 times negative square root of 3. That's going to be negative 6, multiply what's under my radicals, square root of 15. Okay, so if I write this answer all the way out, I get 12 minus 3 square roots of 3 plus 24 square roots of 5 minus 6 square roots of 15. If you notice, all of them are in simplest form. I cannot simplify any of those, which means that's my final answer. And for the very last one, I have 2 times 5, which is 10. I have 2 times negative square root of 2, which is negative 2 square roots of 2. Negative 35 square root of 2. And then the last one, I get plus 7 square root of 4. Well, I can actually simplify all of these, and I get 10. I can combine those two. Negative 2 minus 35 is negative 37 square root of 2, and 7 plus square root of 4. Well, the square root of 4 actually equals 2. 7 times 2 is 14. So when I combine them, I get 28 minus 37 square root of 2.